First, we want to look at degrees and radians. These are kind of the units of measurement when we're talking about angles. So let's just be very basic to start. One circle going around a circle once, or one revolution, is 360 degrees. Hopefully you remember this very well. So half the circle, let's say I start here and I go all the way around in red, that's 360 degrees. If I go half the circle, well, it's half of 360 degrees, 180 degrees. That's as simple as that. We're just trying to measure the angle, and if we go all the way around, well, 360 degrees, one full circle. But we can also say that 360 degrees is equal to 2 pi radians, where we introduce a new unit called a radian. And technically, we can talk about it very shortly, but 1 radian is equal to 1 radius of arc length. So this is, say, 1 meter, the radius of this circle. Well, that's the same. If I go 1 radian, it's about the same as going this distance here. That's about 1 meter as well. Okay? That's all we're really saying. And don't forget, this does show up occasionally. The unit, or the equation for arc length is S equals R theta, where S is where you've gone around. In blue here, this is S. This radius is the radius of your circle. So we're talking about the arc length of some circle, the portion of some circle along it. And then, of course, we've got some angle here, theta. So S equals R theta, the arc length. That's pretty much it here. We talk about this a lot. Radians are the natural unit when we're dealing with trig functions and circles and triangles. We like to use radians if we can, though we can go back and forth. And the last thing we want to say is, well, if 360 degrees is 2 pi radians, we can do some shuffling around and say that 1 radian is simply 180 degrees divided by pi. So if we want to convert from radians to degrees, that's what we'll use. If we want to go from degrees to radians, then we will do the opposite, and 1 degree is pi over 180. So that's all we have to do. If we want to go from 2 radians, same thing. 2 degrees, we just simply multiply by 180 degrees over pi. This will give you the answer in degrees, whatever that is. And similarly, from going to degrees to radians. Again, use radians whenever possible. It's more natural for calculus. It's more natural in your calculators and understanding the unit circle. Radians is the natural unit of angles. These 3 trig functions are the most basic ones, and they are called sine, cosine, and tangent. We can represent them as sine of x, like that, cosine x, and the tangent of x. And everything you learned about SOHCAHTOA and triangles is still true, Pythagorean theorem, and all that good stuff. So let's briefly review that. If I have a right triangle and I have some angle here, well, we can call this the hypotenuse. We'll call this value y and this value x. So let's rewrite these as theta to make our lives a little easier. And using SOHCAHTOA, something very important for physics and math in general, just a quick reminder, again, this is a review, so this should be very well known, but SAW is sine equals opposite over hypotenuse. So that means in the context of this triangle, it's y over h. CAH, adjacent. So the adjacent to the angle theta is x over h. And finally, we have TOA, opposite over adjacent. Opposite this angle here is what we're talking about, so y over x. That is one piece of understanding these functions. We can also relate this to the unit circle, which we will do in the next section very shortly. You want to memorize a lot of different values associated with, for example, sine of pi over 2, cosine of pi. You want to know what these values are as you proceed in your calculus course. So some other basic definitions. This is related to angles and triangles, but there's a very useful identity that you do need to know, definitely. 1 is equal to cosine squared theta plus sine squared theta. You are expected to know this identity off the top of your head, basically. The other trig identities you can look up, there are a few maybe that they might want you to know, but definitely this one. That's why I've written it down. I also want to define the tangent. We can also write the tangent of theta as a ratio of sine theta and cosine theta. So that's another piece of useful information here regarding these. And the last thing I want to talk about is the functional form here, where if I have some function, let's call it f of t now. Hopefully you're very used to exchanging variables and treating them differently. I don't have to say f of x, I don't have to say f of t, I can say f of theta, f of whatever, but that is what better show up as the independent variable in our function. Well, we define a as the amplitude. I highly recommend that you remind yourself the average value of a sine function, the amplitude, the period. You can go to Desmos or Symbolab. These are very useful tools to visualize graphs, do mathematical operations, and all of that sort of thing. Those are two free useful resources. So A is the amplitude, that's how high it is away from the average value. And then B, we can define 2 pi over B as the period of our sine function. That's equal to the period. That's why B is useful. Whatever that coefficient is on t inside the argument. And that's true for cosine and tangent as well. So you want to know what it looks like, the parent functions, and any associated shifts, transforming the function, shifting it up, shifting it to the left, changing the period by multiplying by a constant. Just a quick example here, if y equals 5 sine 2t, you need to know how to read the amplitude and the period as well as graph this thing. See if there's any possible translations or making the function skinnier or fatter to the left and right. That's pretty much it here. There's quite a bit to do with trig functions, and this is just a kind of a basic review again, but make sure you go and know what these things look like, know what the tangent of x looks like, and you'll be well prepared for your calculus course. Now let's talk about the unit circle. This is something very important and fundamental to any trig class. It's a semester-long course in college or high school, typically taken with precalculus or before, and you learn all about the unit circle. So it is something that you are expected to know very well. For example, if I say cosine of pi over 2, well, I know right away using the unit circle that this is equal to 0. Remember that the angle is always measured relative to the positive x-axis. So if I want to find this angle, pi over 6, right here, that I've written in green, well, the x value is going to be cosine. So I can say that the cosine of pi over 6, using SOHCAHTOA and a hypotenuse of 1, because it's a unit circle, so the radius is 1, well, using this and a little bit of math, I can find that it is equal to the square root of 3 over 2. Similarly, the sine of pi over 6 is equal to 1 over 2, 1/2. And so there's all these values that you do typically need to memorize, the special angles they're called. So continuing on here, I'll give you a good way to memorize it here. I know that the sine of pi over 4 is equal to the cosine of pi over 4, which is the square root of 2 over 2. Notice that pi over 4 is about 45 degrees relative to the x-axis. This blue angle here is pi over 4. But I also know that if I want to come over here to 135 degrees, or 3 pi over 4, then it is the same values here, except I have a minus on the cosine because I'm in the negative x-axis here. At this point here, x is negative and y is positive. Similarly, if I was to choose this angle, and it would be 7 pi over 4, because I know a full circle is 2 pi, 7 pi over 4 would be this point here, and this angle all the way around here is 7 pi over 4. The x is now positive and y is negative, so sine of 7 pi over 4 is negative square root over 2. The pi over 4s are quite simple. And then I know that pi over 6 is the opposite of pi over 3. What do I mean by that? Well, if cosine of pi over 6 is root 3 over 2, then I know that the cosine of pi over 3 is 1/2, the opposite of what it is here. And sine of pi over 3 is indeed square root of 3 over 2. And I can do the same thing that I did for the pi over 4 angles in any of the quadrants. Similarly, you want to look at these special angles at the top of the circle, at the left, at pi, 3 pi over 2 down here, and then 0 and 2 pi. For example, I know that the sine of pi over 2 is equal to 1. There is nothing in the x value, it's all in the y value, and the radius of the circle is 1. So the y value at pi over 2 is equal to 1. The x value is equal to 0, so cosine of pi over 2 is equal to 0. I'm not going to go through all of them, of course, but this is the basic idea, and you do need to understand this and have the special angles memorized. Hopefully that helps. I will provide some reference sheets as well as some more in-depth videos eventually on how this works and going about it in a pre-calculus class. But for now, this is a review for calculus, so make sure you have these basic ideas under your belt before you go into the class. Just as we have sine theta, cosine theta, tangent theta, there are 3 more that you need to know about. So let me write these down, because these are the fundamental, most important ones. But we also have 3 more, where we say cosecant, CSC of theta, well, it's just the reciprocal. It's equal to 1 over sine theta. And so if you have these 3, you can find the other 3, but these 6 are typically the full picture when we're talking about trigonometric functions, or just trig functions. So we have sine theta, cosecant theta, which is 1 over sine theta, the reciprocal. Cosine theta is secant theta, or SEC, and that's 1 over cosine theta. And you also have cotangent, which we write as cot, C-O-T, and that's 1 over the tangent of theta, or cosine theta over sine theta, because we know that the tangent of theta is equal to sine theta over cosine theta. This is a fundamental one that you definitely do not want to forget. It comes up a lot in problems, and it is a useful identity to remember in green there. These ones do show up, especially secant, cotangent sometimes, but you should have spent a lot of time on these using identities, understanding these, using the unit circle with all of these, quite a bit in your trig and or pre-calculus course. So we're not going to get into that very much here, but you do need to know this, and these are the basic definitions giving you all 6 of the trig functions. One last thing I want to say is that the useful thing, if I ever forget, I know that, well, sine and cosine, the first letter in sine is S, and the first letter in cosine is C. But notice that so does cosecant and secant. They both start with a C and an S, and I know that the cosecant is related to the sine, 1 over sine theta, because it is opposite. That's how I think about it. It's not sine and secant. It's not the same letter for the reciprocal identities. It's the opposite one, since both sine and cosine have S and C, and cosecant and secant have S and C to start with. So I know that it is opposite. If I ever forget, I remind myself, well, I do know all 6 of them. You better know these for sure, off the top of your head. And cotangent is fairly simple because it has tangent in the name, so I know it's related to the tangent. But the other 2 aren't so simple, and this is the way that I remember them. Sine is cosecant, S to C, and then cosine to secant, C to S. They do not have the same letter to start with. We've been spending a good amount of time talking about inverse functions in this pre-calculus review, and there are inverse functions for all the trig functions. All 6 of these have inverses. We're not going to get into all of them, but we will talk about the 2 most important ones, or the ones that show up in calculus a lot. And if we define a function sine of x is equal to y, well, just as the logarithm is the inverse of the exponent and all the other things, well, arc sine is the inverse of sine. So we would say arc sine of y is equal to x if we wanted to represent the inverse. And we have to restrict the domain. So x is only allowed to have these values. It essentially just lives in between minus pi over 2 and pi over 2. I highly recommend graphing these things and understanding it a little bit more. One other thing, we can also represent it as sine to the minus 1 power of y. It's the same as arcsine. They all mean the same thing. The other function that shows up quite a bit is the arctangent function, or the inverse tan function. So tangent of x is equal to y. Well, we say the arctan of y is equal to x, just like before. And it's the tan to the minus 1, like that. These are the two that show up quite a bit. We'll be taking derivatives and integrating with these functions quite a bit. We can also have the arc cosine, arc secant, all of that. Arc cosine occasionally shows up, but sine and tangent show up quite a bit. We also want to restrict the domain for the arctangent function, and it would be the same almost as arcsine, except we are not including pi over 2, simply because the tangent is not defined at pi over 2. It goes to infinity. We have vertical asymptotes. Make sure you understand what the parent functions look like. That is, what does arctan look like? What does tangent of x look like? No shifts, no stretches, just what does that parent function look like? And that's pretty much it for this video on trig functions. We've got two more before we get into the meat of calculus, start talking about limits. But please, as always, make sure you understand this stuff at a very fundamental level. You don't have to go as deep as you would for a normal class, but you do need to understand applications, how to manipulate these functions, and what they look like, because we'll be using it a lot as we get into calculus material.